Let us start the problems in the chapter of thin cylinders. Before entering to the problems, you have to understand these two formulas should be kept in mind. They are sigma h hoop stress equals Pi into Di divided by 2T. This is the hoop stress. Then sigma T equals Pi into Di divided by 4T. These two formulas should be kept in mind. It is not available in our data books. Okay, sigma T and sigma H. Then Pi is the internal pressure. Then Di is the internal diameter that can be designed. Then T, thickness of the cylinder, can also be designed. Okay, these two formulas should be kept in mind. Then our first problem, actually this KTU 2019 May is an asked question in the university examinations. A seamless cylinder with a storage capacity of 0.0 a seamless cylinder with a storage capacity of 0.025 meter cube. That means the volume of the cylinder is given. Volume of the cylinder is 0.025 meter cube is subjected to an internal pressure of 8 megapascal. Internal pressure Pi is given. 8 megapascal means 8 Newton per mm square. Okay, 8 Newton per mm square. Then the length of cylinder is twice the diameter. Diameter is not given, length is not given, but the relation is given. Length L is twice the diameter. 2 into Di is L. Okay, diameter. Cylinder is made of plain carbon steel 20 CS. Whatever it may be, its ultimate stress is 380 megapascal. 380 megapascal. Megapascal means Newton per mm square. That is ultimate strength. Sigma U is 380 megapascal. And its factor of safety is given as 2.5. Factor of safety. From this we can find out the maximum stress that can be withstand. Maximum hoop stress that can be withstand. That is 380 divided by 2.5. Clear? That much stress can be withstand. That is the allowable stress on the material. These are the given details. Volume is given, internal pressure is given, then length and diameter ratio L equals 2 Di, that relation is given. Ultimate strength of that material, from which we can find out the sigma H or hoop stress can be find out. Then factor of safety 2.5. All these details are given. Then we have to find out the diameter, length and thickness. Diameter, length and thickness has to be find out. First step is to find out the diameter and length. That can easily be find out by the volume itself. So volume is given, from which we can find out diameter and length very easily. Okay, diameter and length. We know the volume equals 0.025 meter cube. It is given in the problem. But what is volume? Cross-sectional area into length. Okay, that is the volume of the cylinder. Cross-sectional area means pi by 4 d square. Pi by 4 d square is the cross-sectional area into length. It is given. This given in the problem is L is equal to 2 Di. It is given in the problem. L equals. Then we can give this value here. Instead of L we can write 2 Di. Okay. Volume V is equal to pi by 4 d square. Into L ആണ് വേണ്ടത് അല്ലേ? Instead of L, it is L into Di can be given here. L into Di. Then give the value V. We know V is 0.025. It is given here. From which the only unknown is Di. In this relation, the only unknown is Di. On simplifying, you will get like this. Then Di is the internal diameter. That is the only unknown in this relation, from which Di can be calculated. This much meter. Why? Volume is this much meter cube, 0.025 meter cube. Then the obtained value of the Di will be in terms of meters. So Di is equal to this much meter. that can be converted into millimeter into 10 raised to 3, that is 251 mm is the answer, first answer. Then length L is nothing but 2 di. Okay, 2 into di is given here, and 2 into di is equal to 503 mm. Then these two answers are obtained. The only thing is thickness. Thickness has to be find out by means of hoop stress relation. Go for next step. Step 2, thickness 2. Thickness T can be find out using this relation. Sigma H. Sigma H is equal to Pi into di by 2T. That should be kept in mind, this relation. This formula. Sigma H is equal to Pi into di divided by 2T. Noka. Step 2, thickness. We know sigma H for hoop stress. Hoop stress is hoop stress is nothing but the permissible stress. How much stress can be withstood by that material, cylinder material. Ultimate stress is given, then factor of safety is 380 divided by 2.5, 150 Newton per mm square. This material is capable of withstand this much stress. Capable, safely. Safe ആയിട്ട് അതിന് ബെയർ ചെയ്യാവുന്ന സ്ട്രെസ് എത്രയാണ്, അത് നമുക്ക് ഹൂപ്പ് സ്ട്രെസ് ആയിട്ട് എടുക്കാം. ഓക്കെ, ദെൻ സിഗ്മ എച്ച് ഇവിടെ ആ വാല്യൂ കൊടുക്കാം, 150 Newton per mm square. That is equal to Pi into di divided by 2T. Pi is given in the problem as 8 Newton per mm square. Di is obtained as 251.2. That can be given here. Then 2T, the only unknown is T. From this relation, T can be calculated as 6.7 mm. Okay, what a simple problem it is. We may go for next problem. After completing this one, the first problem, go for the next one. A seamless cylinder is very similar one. The only the data is something, some changes in data only. Okay, the volume, pressure, അതിലൊക്കെയുള്ള numerical changes മാത്രമേ ഉള്ളൂ. The same problem. Okay, the seamless cylinder with a storage capacity of 0.03 instead of, sorry, the volume is 0.03 meter cube, it is given. Internal pressure is also given, 22 megapascal, that is 22 Newton per mm square. Then as in the previous problem, the value of sigma u and factor of safety are given. Sigma u and factor of safety both are given. Another relation is the dimension, the length of cylinder is twice its internal diameter. That relation is also the same. That is also same. Solution. Step 1, finding the diameter and length. Diameter can be find out by using the same way. That is volume equals cross section area into length. Cross section area is this one, pi by 4 d1 square into L. L is nothing but 2 di, 2 into diameter. Okay, then pi by 4 d1 square into 2 di. Same thing. Then the internal, the only unknown is di. That di can be calculated from this relation. Then di is equal to 267 mm and length 2 di is equal to 534 mm. Okay. In the same manner, the step 2, thickness. Thickness T can be calculated by knowing this relation. If you know this relation, sigma h, hoop stress sigma h is equal to Pi into di by 2T. There, sigma h equals, sigma h means hoop stress. Permissible stress, hoop stress. Permissible stress. Ultimate stress is 390. Factor of safety is 3. Then the permissible stress is 130 Newton per mm square. This can be taken as hoop stress. Then hoop stress sigma h is equal to this relation Pi di divided by 2T. പഠിക്കുക. Then sigma h is 130, that is given here. Sigma h 130. PI 22 Newton per mm square ഇവിടെ കൊടുത്തു. DI ഇത് ഇവിടെ കൊടുത്തു. 2T, the only unknown is T. From this T can be calculated as 22.6 millimeter. That these two problems are very similar. ഏതാണ്ടൊക്കെ അതുപോലൊക്കെ തന്നെയാണ്. There is only very small difference. Third problem. A thin cylinder of 2.5 meter diameter is required to convey water under a head of 250 meters. Under a head of 250 meters. Actually it is not pressure, but the pressure head is given. Instead of pressure head is given. That is the only difference. In the previous problem, the internal pressure is given. But here, the pressure head is given, from which we can calculate the pressure. P can be calculated. P is equal to rho gh. Okay, h is given here. Instead of Pi, h is given. Pi is equal to rho gh. Rho is the density of water. G is the acceleration due to gravity, 9.81 meter per second square. G. Then h is 250 meters. Is given. From which we can calculate the Pi. That is the only difference. Determine the thickness of the cylinder. If the allowable stress in the pipe material is 90 Newton per mm square, sigma h, hoop stress is directly given. Hoop stress is directly given. Okay. Diameter is given in the problem as 2.5 meter. That can be converted into millimeter as 2500 mm. 2.5 into 1000. 2500 mm. That is the diameter. Then pressure head h is given as 250 meters. Meters. Then allowable stress is given as, that means hoop stress is given as 90 Newton per mm. These are the given details. From here, first step is to find out the pressure head h. Pressure Pi. Pressure head h is given as 250 mm. Not mm, 250 meters. 250 meters is the pressure head. Then pressure Pi, internal pressure Pi, can be found out by using this relation. Fluid mechanics. Rho gh. Pi is equal to rho gh. Rho is the density of water. Inside the fluid is water itself. So water, its density can be taken as 1000 kilogram per meter cube. 1000 kilogram per meter cube. So rho can be taken as 1000 itself. Kilogram per meter cube, 1000. G 9.81. H is given in the problem as 250 meters. This is in SI unit, SI unit, SI unit. No problem. But what will be the obtained value of the Pi? What will be the unit of obtained value of Pi? That will be also in SI unit. That means Pascal or Newton per meter square. Rho 1000, 9.81, 250. ഇത് ഗുണിക്കുമ്പോൾ നമുക്ക് കിട്ടുന്നത് എന്താണ്? ഇന്റേണൽ പ്രഷർ കിട്ടും. ഇറ്റ്സ് യൂണിറ്റ് വിൽ ബി പാസ്കൽ ഓർ ന്യൂട്ടൺ പെർ മീറ്റർ സ്ക്വയർ. എന്താ കാരണം? ഇത് ന്യൂട്ടൺ, ഇത് SI യൂണിറ്റിലാണ്, ഇത് SI യൂണിറ്റിലാണ്, ഇത് SI യൂണിറ്റിലാണ്. The obtained value will be in SI unit. That is Pascal, Newton per meter square. That may be converted into Newton per mm square. എങ്ങനെയാണ്? Newton per meter square. നമുക്കറിയാം 1 meter is equal to 1000 mm. 10 raised to 3 mm. 1 meter is equal to 10 raised to 3 mm. അപ്പോൾ 1 meter square is equal to 10 raised to 6 mm. അപ്പോൾ അതുകൊണ്ട് 10 raised to 6 കൊണ്ട് ഡിവൈഡ് ചെയ്യാം. ഇതിനെ 1 meter സ്ക്വയറിൽ ഇത്രയും ഫോഴ്സ് ന്യൂട്ടൺ, 1 mm സ്ക്വയറിൽ ഇത്രയും ഉണ്ടാവില്ലല്ലോ, വളരെ കുറവല്ലേ ഉണ്ടാവുള്ളൂ ഇതിനേക്കാളും. 10 raised to 6 കൊണ്ട് ഡിവൈഡ് ചെയ്യാം. ന്യൂട്ടൺ പെർ mm സ്ക്വയർ. ദെൻ Pi is equal to 2.4525 Newton per mm square. അങ്ങനെ ചെയ്യുമ്പോൾ അങ്ങനെ കിട്ടും അല്ലേ? 6 സ്ഥാനം നോക്കി. 2.4525 Newton per mm square will be the internal pressure. Only difference. And remaining is same. Sigma h. Sigma h is given in the problem itself. 90 Newton per mm square. Then hoop stress relation. Hoop stress sigma h is equal to PI into DI divided by 2T. Sigma H can be written as 90. PI is 2.4525 is obtained. Then DI is given in the problem. This much mm. ഇതൊക്കെ mm അല്ല എടുക്കും കേട്ടോ. ന്യൂട്ടൺ പെർ mm സ്ക്വയർ അല്ലേ. ഇത് ന്യൂട്ടൺ പെർ mm സ്ക്വയർ ആയതുകൊണ്ട് ഇതിനെ ഞാൻ ന്യൂട്ടൺ പെർ mm സ്ക്വയറിൽ എടുക്കൂ. Then here also taken in terms of millimeter, 2000 mm divided by 2. Okay. Then you will get the thickness. T is equal to 34 mm. 34 mm. This is the final answer. Clear? Simple. Okay, you have to do. Then fourth problem. A thin cylindrical pipe of internal diameter 2.5 meter length. A thin cylindrical pipe of internal diameter of the pipe is given as 2.5 meter. Very large pipe, penstock type, 2.5 meter, contains a fluid of pressure of 2.87 Newton per mm square. Internal pressure is given. Pressure is directly PI is given, D is given. Determine the thickness of the pipe wall. T has to be found out. If the hoop and axial stress in the pipe is not to exceed 160 Newton per mm square and 146 Newton per mm square respectively. Very simple one. Sigma H is given as 160 Newton per mm square. Sigma T is given as 146 Newton per mm square. Okay. Both are given. Sigma H is given, Sigma T is given. Then DI means internal diameter of the pipe or cylinder is given, a thin cylinder is given as 2.5 meter. Okay. That can be converted into millimeter as 2500 mm. This is the diameter. Then internal pressure of the fluid is given. PI equals 2.87 Newton per mm square. This is the internal pressure. Then allowable hoop stress is given as 160 Newton per mm square. Allowable tensile stress or longitudinal stress is given as 146 Newton per mm square. These are the details. American details. വളരെ സിമ്പിളാണ്. ആദ്യം ഹൂപ്പ് സ്ട്രെസ് വെച്ചിട്ട് ഡിസൈൻ ചെയ്യാം. നമ്മൾ ആദ്യം ചെയ്യേണ്ടത് ഹൂപ്പ് സ്ട്രെസ്സിൻ്റെ റിലേഷൻ വെച്ചുകൊണ്ട് ആദ്യം നമ്മൾ ഡിസൈൻ ചെയ്യും. Then second case, we will design as per a longitudinal stress. Taking longitudinal stress as the criteria, we will design again. Which one is the larger one? Larger value will be selected. Larger value of thickness will be selected. Clear? That is the procedure. Okay. Case 1. Consider hoop stress. Hoop stress. Considering hoop stress, we will design the thickness. We will get one value. Okay. Considering hoop stress, sigma H, our relation is PA dA divided by 2T. That is the hoop stress relation. Sigma H is 160, PA is 2.87 into 2500 mm, PA divided by 2T. Okay. From this relation, the only unknown is T. Only unknown is T. Then you can find out the value 22.4218 mm. Thickness is obtained. Considering hoop stress. Then, considering axial stress or longitudinal stress, consider thickness. In this case, the relation is something different. Sigma T is equal to numerator is okay. PA into DI divided by 4T. Not 2T, is 4T. Then giving the value, sigma T is given in the problem as 1.146 Newton per mm square. This is given here. Pressure is given in the problem as 2.87 into DI is 2500 divided by 40. Only unknown is T. T can be calculated. 12.285. The previous case it was 22 point. Okay, here it is 12.5. Larger value of the thickness is equal to 22.4218 mm. That is taken as the final answer. This is the answer. Larger value is selected. Okay, ഇന്നത്തെ അവസാനിപ്പിക്കാം. നെക്സ്റ്റ് തിക് സിലിണ്ടേഴ്സ്. മറ്റൊരു വീഡിയോയിൽ തിക് സിലിണ്ടർ. The thin cylinder here find itself.